Alright, good afternoon everyone. Welcome to today's Sec 4E math lesson with me, teacher Jason over here. Alright, so just make sure you're in the correct lesson with me, Sec 4E, teacher Jason with me. Without further ado, let's get on to further on our revision with Sec 4E math lesson. And let's see where we are going to get to. Alright, so now, just some general pointers. Please be patient and understanding as I'm going through the lesson. Okay, observe gracious and respectful behavior when you're typing your responses. And lastly, ask good and relevant questions as accordingly. Alright, so what are we going to revise? Again, just these two main big topics over here. Coordinate geometry and vectors, and what kind of questions can they possibly be coming up. But again, let's start off with further revision over here. So let's start off with something that might have seen in Sec 1 already, general equation of a straight line. Y is equals to mx plus c. Okay, x and y here are any points on the line. And when we talk about these two things over here, m and c, okay, m over here and c over here, I hope you all realize it by now. The m over here is what we call the gradient. And c over here is what we call our y-intercept. Alright, y-intercept of that particular line. Alright, so this should be going into you, should be fixed into you already as when you find the equation. But now supposedly, let's say before you find the equation, you might have to find certain stuff. In this case, finding gradient of a straight line. So suppose you have a straight line from A to B. A is this point, B is this point, respectively. If A and B are 2 points on this line, I can say that it is none other than y2 minus y1 over x2 minus x1. Is there another way to write it? Can anybody tell me? Is there another specific way for me to write such a gradient equation? Okay. Is there another way? So take note, one way to write it is, this is y2, y1, y2, y1. Okay, if it's x2, x1, x2, x1, should be at the bottom. Is there an alternative way for me to write this? Does anybody know? Or anybody want to give it a shot? Okay, so take a look. If I actually multiply the top and bottom by -1, I can actually write the other way around. Okay, very good. Alright, I see some responses. Good job. Okay, so y1 minus y2 over x1 minus x2. Take note, my coordinates over here must make sense. If it's 1 at the top, 1 at the bottom, 2 at the top, 2 at the bottom. In that same column, it should correspond accordingly. Okay, now with respect to gradient as well as other stuff, okay, gradient is used to find my equation of a straight line. But sometimes they don't really want the equation of the straight line. They might want something else. So say for example, length of a line. So what happens? Okay, does anybody recall, in this case, for 2 points on the line, where does this concept stem from before I provide you with the formula? Okay. So in order to understand this concept over here, there is a particular mathematician that actually helps you understand this way easier. And it starts with P. Does anybody want to give it a try? Who is this famous mathematician that I'm talking about? Alright, I see some responses. Okay, it starts with P over here. You're famous, Pythagoras. Very good, Pranav. Okay, so Pythagoras tells us that if we actually apply our a square plus b square, in fact, your a square is the distance, x2 minus x1 square, plus b square, which is your y2 minus y1 bracket square. This is none other than ab square. If I were to square both sides, and it removes my square root. Or in this case, you can write it the other way around as well. Okay, just switching your x1 minus x2 and y1 minus y2. Okay, take note, in this case, you can write it the other way, but my recommendation is try to keep it in this general convention, which is in this case, if it's 2 over here, it's going to be 2 at this side, 2 on the right, 2 on the right as well. Similarly, 1 on the right, 1 on the right, left, left. Keep it with the subscript at the bottom the same manner. If it's at the left, maintain it at the left. Yes, no, Denise, do I need to put a square? I'm finding AB. Am I finding AB square? So take note. The distance is the square root. All right, take note of the square root. Oh, you mean that square there? Yes, thank you for the note, Denise. Okay, so there's a square. Thank you for the correct note. Okay, thank you for the note. Okay, so remember your squares, all right? Okay, thank you for the note, Denise. Now, with these concepts over here, what kind of questions can they come up with? So that's where we have our first bubble question. Okay, so I have A and B on the point. So how do I find them? So this is my A, point on the y-axis, B, point on the x-axis respectively. So how do I find? What do they want? Take note. Okay, look at what they want and how do we solve. Launching my bubble launcher in 3, 2, 1, let's go. Alright, let's see how do we fare over here. Let's go. Alright, just remember along the way when we are doing this, how do we tackle such questions? Alright, let's see the responses so far that I have. Alright, I have one good response over here. You have about 40 seconds left. Okay, so one thing to take note, whatever you have, you write it down first. So I have the equation of my line. Okay, equation of my line. So let me write down first. So I have 3y plus x is equals to 15. So what do I have? Okay, I see some real responses over here. Take note. What are your calculations over here? Be very careful when you do your calculations. Last 5 seconds. Okay, be very careful when you calculate it. Last 2. Okay, let's see my responses over here. Be very, very careful when you calculate your coordinates over here. Alright? I understand, Chen Chen, no time. Okay, no worries. Okay, for the next few questions, I will give you all some more time. Alright? So what happens? First up, I want to find A. A is your y-intercept. Y-intercept is when x is equals to 0. So from here, that's where you have your y-intercept, which is y is equals to 5, and henceforth my coordinates of A is 0, 5. Now just a recap over here, because to find the length AB, I need my coordinates B. So can anybody tell me to find this coordinate over here? What should I substitute into this equation over here? Does anybody wants to give it a 5-second write out answer? What should I be writing out there? What is the coordinate I should be writing out? Okay, so I want to find the coordinate B. So what should I do? Okay, A is when x equals 0. B is when? Take a good note over here. Let's think about it. B is at my x-axis is when? Alright, very good. When y is equals to 0. Perfect. So you just sub it in and you realize you have just have x is equals to 15. So this is your B. Now take note over here. Okay, that is where some of you may have made a mistake over here. When you want to find AB, okay, depending on how you do it, okay, it's going to be 0 minus 15, or in this case I will do 15 minus 0 square, 15 minus 0 square plus 0 minus 15 square. Now take note, when you take the square, it is positive on both sides. So it is actually going to be none other than 15 square plus 5 square. Take your calculator, press it, you're going to get a square root of 250, which thus gives you the answer of 15.8. Alright, so be very, very careful. And remember, answers always live in 3SF. So that's where I have 15.8 units. Always leave your answers in 3SF. That's why my answer is answer number 1. Okay, so be very careful. Some of you will make 2 because when you square root, you include my minus sign. Okay, so just be very careful. I only have these 2 answers. But for the rest, not too bad. Good job so far. Okay, just be careful of your minus signs. Okay, now following up, what type of questions can I have for coordinate geometry? Okay, so I want to find the equation of the line which passes through another point and is parallel to AB. So what does it mean to be parallel? So A is 0, 5. B is 15, 0. That's to write it out for you. I want it to pass through a point and it's parallel. So what does parallel mean? Okay, So I'll give you all some time to start now before I start the bubble launcher in 30 seconds. All right, I'm going to give a 30 seconds head start before I start the bubble launcher. All right, just start it first. Okay, give it some shot. I haven't started yet, so I'm gonna just let you all start first before I give it my own try. Okay, it's the same related question. In fact, bubble questions 1 to 3 are related. All right, launching the bubble launcher now in 3, 2, 1. Let's go. All right, that's good. Okay, the responses are coming good. That's good. That's good. So take note. I want an equation of the line which passes through this particular point, and it's parallel to AB. So what does it mean? Okay, seems like this question is not an issue. Okay, last 30 seconds. Hang in there with me, guys. Last 18 seconds. All right, give it a shot. For the rest of you to answer, you still have 10 seconds left. All right, looking at the keywords. Last 5. Last 3, 2, 1. Okay, I think some of you got confused over here. Okay, but take note regarding my coordinates. Okay, first things first, I think that's where the mistake comes in. Okay, parallel to AB. Can anybody tell me, when I say parallel, what can I talk about my gradient? What can I say about the gradient when I say parallel? Does anybody want to give it a shot? What can I say about the gradient of this line? Very good, Denise. Anybody else wants to try? What can I say about the gradient? Right, okay, let me wait for some responses. What do you mean by that, Chen Zheng? Okay, what do you mean by that? When I say about the gradient, in fact, if you were to talk about the ratio, they should be the same, no? Because when I talk about the gradient, essentially parallel, it's supposed to look like this. When I talk about parallel lines, two straight lines, okay, it's not really this way. Ratio of the gradient. Okay, let me take a look. What do you mean? Okay, when I talk about ratio of the gradient, no, the ratio should not be different. In fact, because the gradients are the same, when I compare the ratio should be 1:1. Take note, because when I say parallel, the gradients are the same. So henceforth, if let's say the gradient of this is, if I were to calculate, take note, that's where you'll fall into the trap. 5 and 0 should be, in this case, the y coordinate. So at the numerator, the other side is 0 minus 15. Take note, the corresponding, if they fall into the same bracket, they should fall in the same column. So 0 minus 15. So that's where I have -1/3. And hence, if I compare the ratio, if this is -1/3, this is -1/3. If I take the ratio, it should be 1:1. So I think there might be some confusion over here, but take note, the ratio should be the same. Is that okay? Now following up from there, once you have the gradient, y is equals to -1/3x plus c. Okay, and then what happens? You have the point. With the point, you just substitute in. So that's where you just substitute the points c, 30, 15 into my line, which is in this case into y is equals to -1/3x plus c. That's why we have it. Okay, before I carry on, Chen Zheng, do you understand my explanation to why the ratio should be 1:1? Okay, perfect. Okay, let me move on over here. Okay, so from here it's just substituting. So that's where I have, okay, just substitute my c, 15 is equals to -1/3, 30 plus c. Okay, just substitute in the coordinates. That's where I have 15 minus 10 plus c. Okay, carry on my working over here. I'll just carry on from here. C is in this case 25. So therefore, my answer is going to be y is equals to -1/3x plus 25, which is exactly number 4. So just take note when you do the calculations, just be very, very careful. Okay, now moving on to the last related question with regards to this question over here. So if A, B, C, D is a parallelogram. Now, C is actually a very high point up, so it's actually going to be somewhere, say, here. Okay, so this is C is going to be 30, 15. So I have a point very high up. C is 30, 15. Very high point up. Okay, what does it mean? Okay, it's a very, very embedded question when I want to draw A, B, C, D. So that means if I were to draw my coordinates, so A, B, C, and D, somewhere here. So D is somewhere very high up, let's say somewhere here. Okay, so A, B, C, D. How will my parallelogram look like? Okay, yes, we can label, yes, oh sorry, yes, I need to label the points, that's right, for you all to answer. A is 0, 5, B is 15, 0. Alright, this one, 1 minute 30 seconds, a bit long, but let's see how you all do. Alright, launching my bubble launcher. Alright, take note what does it mean. In 3, 2, 1. Alright, this is a bit of a higher thinking question. Let's see how you all face. Alright, let's go. Okay, very nice. Take note. I have A, B, C, D. Now, the first question to ask yourself, when I talk about A, B, C, D is a parallelogram, what does it mean first? Picture it accordingly. Okay, about 1 minute left. Hang in there with me. Okay, so seems like this one I'll need to explain a little bit more, but don't worry about it. Okay, it's alright. Okay, so if I picture a parallelogram, say for example, okay, this way. This is my parallelogram. Okay, maybe I draw it a little bit slanted. Okay, maybe something like this. Okay, I'm gonna erase certain parts of it. Don't worry about it. What can I say if these are my points? If I were to sort of zoom in a bit, last 3 seconds. Okay, so there's some confusion. Let me just help you out. So this is A, let's say. This is B. This is C. This is D. So I know a few points over here. I know A. I know B. I know C. But I don't know D at all. I can't find D. So what can I say in this case about my gradients? No worries, Senten. Let's just try to think about it all together, alright? Okay, I'll try to extend some time, okay, for the rest of the questions. I'll give a 30-second extension for the rest of the questions, alright? So don't worry. So what can I say about my gradient over here? I hope you got my thinking process over here. So let's try to see, okay? In a parallelogram, what can I say in this case about my gradients? Say in this case, BC and AD. Can anybody tell me? What can I say about these two gradients? Or in fact, A, B, and DC. What can I say about either of these two gradients? A, B, and DC. Either or. Doesn't matter. Correct. Alright, Denise says they are the same. In fact, we can apply them over here. They are the same. So, if we were to calculate, say, the gradient of AB at that time, we know AB is in this case, okay, -1/3. We have calculated before. Our gradient before that is -1/3. So the gradient in this case, y minus 15 over x minus 30 should be -1/3. Correct? Make sense? It should be this case over here. So let's view it up. Okay? If I want to have a parallelogram like this, okay, let's picture. Or if this is not clear enough, this should be the idea in mind. Okay? This should give you the idea. And we can actually monitor the movement to how much it moves down and right. So let's picture. From over here, how much has it moved down to meet B? So this is actually, if you recall, from here 5, it actually moves 5 units down. Correct, in this case the same ratio, very good. And then we have In this case, same ratio and the same movement. So 15 units to the right. So that means for x to reach here, it's gonna be 5 units down. So therefore, I have x minus, in this case, let me just see. It's not 5. Let me just take a look first. It is, yes, no, it's not. It's not x, sorry. For it to go down to 30, sorry for that. Let me not go to 30 first. Let me just see first. Okay, it's not 30. For y to go down to 15, because I'm going down. So y to go down to 15, okay, because I'm going down, you see. Down follows my y-axis. Y-axis. So that's where I go from y. 5 units down gives me 15. Therefore, the y-coordinate is 20. Similarly, now it goes 15 units, right? So that means from my x part to 30, to go from this part to B, in this case, this way over here, it has to go from, in this case, x plus 15. Let me just take a look. X 15, it's gonna go right. So to go back left, sorry, so x plus 15 is equals to, let me just take a look. Okay, I might have confused myself. Let me take a look first, sorry for that. Yes, correct. X plus 15 is equals to 30. Because what happens, x is initially here, go 15 units to the right, it goes to 30. Okay, x 15 units to the right, it goes to 30. X 15 units to the right, it goes to 30. So it's more like backtracking. So therefore, I have x is equals to 15. And these x and y, what do they correspond? They correspond to my x and y over here. So that's why, moral story, just stop them in. So therefore, my coordinates D is actually 15 to 20. And that's why my answer is number 2 over here. Okay, just make sure you know when you are moving my x's and y. Okay? So just gather some response. 1 if you are clear, 2 if you are half-half, 3 if you are unsure, and need me to go through again. One if you are clear, 2 if you are unsure, 3 if you need me to go through again. Okay, seems like the responses are going good, so I will move on, yeah? Let me just move on. Okay, so the next part of the question, bubble question number 4. It's a little bit different. So what happens? I have a line. Let me just draw the line for you to see. I have a line. Y is equals to 3x minus 2. Now this tells me when x is equals to 0. Let me just draw it out. X equals 0, y is minus 2. And then when y is 0, okay, x is 2/3. So what does it mean? What does it mean over here? If I actually reflect it about this line. What does it mean? This is a very interesting question. So think about it when I reflect. What does it give? Alright, launching my bubble launcher over here in 3, 2, 1. Alright, and let's go. Alright, you have 2 minutes for this. Think about this. Okay, what do I do when it's reflecting? Alright, let's go. Alright, very good note. Okay, I think I see some good responses. Be careful not to assume certain stuff over here. We have about 1 minute, 30 seconds left. One minute, 20 seconds left. Alright, hanging there with me, guys. Okay, more responses are alright. Okay, but just hanging there with me. One minute left for those who are doing. Just hanging there with me. Try to give it a shot. Take note, is it minus 2? Yeah, that's correct, but which option is it? Yeah, you got the first part correct, but which option is it, Chen Chen? You have about 40 seconds to think about it. Okay, click that option and see what you have. Look at the options very closely, Chen Chen. I'm not going to give you too much hints, otherwise it will spoil the party. Last 17 seconds over here. Alright, for the rest, give it a shot. You have about 8 more seconds with me. Hang in there. Last 5, 4, 3, 2, 1. Okay, I would say 33% of you got it correct. It's fine. This question is requires some higher thinking process. So let's see how do we solve this. Now, when I talk about reflection, right, it means this is my mirror. So all I'm doing is I'm just flipping this line up to achieve another line over here. Now, when I reflect, let's try the picture. Does this distance over here, when I reflect it over, equals to this distance over here? Okay, it's going to be the same, right? But what, yeah, that's right, Denise, they are going to be the same. But what is my value over here? Does anybody want to give it a shot? What is my y value over here? Since the distance I'm talking about, they are the same. Very good, Chen Cheng. It's going to be that value. Very good, Denise. Perfect. They are the same. So when I view them as coordinates over here, so they are the same. So if I view them as coordinates, this is going to be 2. Okay, positive if you view the axis. So therefore, now with this notion over here, how do I find my gradient? So now you have the coordinates. This point over here, take note, is just my x-intercept. So that's where I have actually provide you all. But how do I find it? Again, I have the line y equals 3x minus 2. When y is equals to 0, that's how you find your x-intercept. Okay, 3x is equals to 2. Normal manipulation. X is equals to 2/3. Then how do I find my gradient? Gradient, take note. Coordinates are labeled as, this is 0, 2. This is 2/3 and 0. So from there, how do I do it? Remember, it's y2 minus y1 or y1 minus y2, but you have to be consistent. Yes, gradient is negative, that's right. So in this case, but proper calculation, gradient is negative, that's right, Denise. But proper calculation, 2 minus 0 over 0 minus 2 over 3. Again, let me emphasize, same column for y. If y2, y2, y1, x2, x1. So 2, 0, sorry, that 0 is not over there. Let me just rewrite it. The 2 and 0, 0 and 2/3. Okay, they should be this way. And column-wise, they should follow accordingly. Because if it's y2, and then it should follow x2. If it's y2, sorry for that. Let me just use this marker, y2, this is x2. Take note, can we just flip the signs? Is it always true? Okay, depending on how we actually flip it, the gradient may not be just flipping it up. Okay, so we always actually have to calculate the gradient straight depending on the coordinates that we have. Is that clear enough, Denise? Okay, x2, x1, so let me just go back again. So this is x2, and then therefore, so this is y2, so therefore this is y2, and henceforth this is x2, so x2. So similarly, y1, y1, x1, x1. Column wise, just take note they have to be in the same manner for the subscript. Okay, any questions so far? Denise, you are able to understand me for what I mean for the gradient? Are you able to get what I mean? Okay, so while waiting for a response, yep, okay, if you're unclear during the Q&A, I'll be more than happy to answer your query. Alright, now let's move on. Coordinate geometry done. Let's go on to vectors. So how do we represent vectors over here? So vector, usually represented as a column vector. Say in this case, AB. Okay, A over here, we represent the number of units along a positive, take note, it's not negative or anything, it's always positive, of which direction? There are only two directions, X or Y. Choose one. Which direction are we looking at? X or Y? Okay, positive. If I look at A, it's going to be the positive. Very nice. X direction, and then Y represents the positive Y direction. So just take note over here. A represents X because X over Y usually. B represents the Y direction. Okay, so just take note over here when we do column vectors and how we boil down. Okay, because usually for vectors, we don't usually just have one vector. We have sometimes multiple vectors to give my resultant vector. But that's where we have two cases. Case number one, triangle law of addition. So can anybody tell me AB plus BC, do I get a vector? And in this case, what vector do I get if I have one? What is the vector that I get? Very good, Pranav. That's good. What do you mean? What was the yes, Pranav, before that? Okay, yes, the vector I get is AC. And in this case, P plus Q is equals to R. Okay, so that's what I have over here. Because just think about it, to get the resultant vector, let's link our vectors together. P and Q, do they link up? Okay, the direction flows and it gives me AC. Similarly, representing P and Q gives me my R. That's the notion over there. Okay. Now, I have another case whereby, let's say, AB plus BC. In this case, does it give me a resultant vector? Yes or no? And if yes, what resultant vector does it give? Okay, Denise says yes. For the rest, take a close look. Look at my arrows again. Do they actually give me a resultant vector? Take a very, very close look. Yes, correct. So one thing is very important, guys. If you realize if you have A to B, I cannot plus BC. It's stuck. So I actually need to do something. One thing over here, I need to flip the vector. By flipping the vector, in this case AB, I don't have to flip it. But by flipping the vector, what am I doing to this vector? I am doing by multiplying it by, let's recap, -1. So it becomes C to B. Okay, no, B to C is negative C to B. It's the opposite. So if I were to flip this around, I need to multiply this by -1 to get it to BC. Because BC, take note, it's the multiplication of -1 to give me CB. Or similarly, to get BC, CB multiplied by -1 is BC. And from there, you realize that's where I have AB minus CB. This then gives me AC. Okay, similarly over here, P plus Q doesn't work out. So I need to flip my vector to give me P minus Q. In this case, to give me R. Okay, so this is actually minus Q. Okay, Pranav, I understand it's confusing, so let's take note. First step first. AB plus BC. Do I get a resultant vector, Pranav? I don't, right? Because I'm stuck here. So what I need to do? I need to ensure that I want to get this resultant vector. So how do I flip this as suggested by Denise? I multiply this vector by -1. Okay, now you get it. So remember, flipping of the vector, very important. The keyword here is -1. -1 over here. Alright, so take note. Yes, we are almost there, Denise. Not yet bubble question. Just one more concept to go. Position vectors. Lastly, when we talk about position vectors, because sometimes column vectors, in order to find them, we need our position vector. So position vector, remember, is reference to the origin. We call it OA, which is XY. Now, in this case over here, whenever we talk about position vectors, there is a particular way we can do it. Does anybody wants to try PQ? If I were to express it in terms of position vectors, what is the equation I'm looking for? When I say PQ, remember, I think I did this lesson with you all. Second letter minus first letter. So what do I mean? Second letter minus first letter. Very good. Okay, remember the notion over here. I have OQ minus OP. This is the notion to how I express my position vectors. Okay, OQ minus OP. Okay, and if you know this shortcut, it will be good. Okay, it will be perfect for you. Okay, ideally, if you know this, everything will go well. Okay, now, okay, this is an essential shortcut that I feel you all should do. Now, finally, we are moving on to our bubble questions. In fact, all the way onwards, it will be bubble questions. Yes, in fact, you have quite a bit. Okay, so from this moment onwards, will be bubble questions all the way to see whether you understand your concept. Okay, so let's go. First up, bubble question number 5. So first one should be quite okay. Launching the bubble launcher. 3, 2, 1. Let's go. So I want PS. Look at the question carefully first. I have a lot of information, but take note. I want PS. So how do I do it? I have P, I have S. So it's just quite straightforward already. Okay, responses are going good. You have 30 seconds left. Hang in there with me, guys. Okay, the rest of the information are important as well, but take note, what do I need to do? There's an important information over here, but we do not need to use it yet. I'm just highlighting to show you that it exists for later on. Okay, responses are going good. Last 5 seconds for those who are yet to key in your responses. Last 2, 1. Okay, not too bad. Majority of you got this right. Let's see what we have. Okay, so I have PS. So remember, I just went through this before. If you know the second alphabet minus the first alphabet. So I have OS minus OP. Now take note what is OS minus OP. OS, negative 3 over 3. OP, when you label it, take note it's negative 3, negative 6. It's negative 6, 3. X at the top, Y at the bottom. Once you have this, negative 3, 3 minus negative 6, negative 3. You're going to have negative 3 plus 6. 3 plus 3. That's where you get 3, 6, and henceforth 1 is your answer. Okay, so that's one thing to take note. Shortcut faster. Okay, in fact, this should be the ideal way of doing it so that you don't confuse yourself with why if there's PO. Some of you, I know you all do it PO plus OS, but that means you need to multiply this by the negative 1, which might confuse you. So always follow the notion OS minus OP. Alright, okay. I hope this is good. Okay, so seeing the responses, I think it's going good. Let's move on. Now, I want to find the magnitude of PS. So of course, I need to give you the vector first, which is this. Okay, I'm not going to ask you to spend extra time. PS is this. How do I find this notion? And what does it even mean first? Okay, launching the bubble launcher. What does this mean? In 3, 2, 1. This one not very long. You have only 30 seconds. But it should be fine in a while because I think some of you are clicking the calculator already. Launching it now. Okay, that's good. I'm seeing the responses streaming in. What does it mean? Okay, going good. Take note, how do I actually do my how do I do this question in the first place? What does the 2 lines mean? Alright, last 3, 2, 1. Okay, some of you, I think you all fall into the trap, but 60% of you got it right. That's a good sign. No, I would say 50%. Very interesting. So take note, this is actually your magnitude of a vector, which is none other than your Pythagoras theorem. So that's where I have, take note, a square plus b squared. In this case, your magnitude, a square plus b squared. Okay, that's where you do it. I think some of you accidentally did it this way. 3 plus 6 whole thing squared. Okay, take note that's not correct. Okay, we need to square each of the components over here. Which part you don't get it, Pranav? I think I missed it out. Is it this question? You mean the previous part? Did I miss it out? Okay, no worries, Denise. I'll go a bit faster. Square root 45. Okay, maybe at the end of the lesson, if you don't get it, let me know. Okay, so square root 6.70820, square root of 45. This is none other than 6.71. Okay, noted, Denise. But take note first. I think Pranav has a query. So just let me answer his query first. Pranav, what is your query? Or have I answered it just now? Okay, noted. Okay, let's move on. Bubble question number 7. Okay, so right now I have PR. Okay, so in terms of P and Q. Okay, so what does this mean? Okay, so I've yet to answer the notion. Take note, P over here is actually my OP. And also Q over here, I forgot to write down, it's actually my OQ. Yeah, this I have to emphasize, apologies. So express PR in terms of P and Q. Now what do they mean? Look at the diagram. Okay, I'm not going to give too much hints. Launching the bubble launcher in 3, 2, 1, let's go. What do they mean? Okay, OP is P, so it's this way. OQ is Q, so it's this way. So what do I have? I want PR, so what is it? Okay, very good. No, seems like most of you got it down, so very good job to everyone, you guys. Okay, such a good job. You guys are doing good, doing awesome over here. Hanging there with me. Last 20 seconds. So take note, I want to find the vector PR. So what is it? PR, take note, is this vector over here. Last 5 seconds. Last 3, 2, 1. Alright, most of you got it down, very good. But for those who did not, let me just go through as accordingly. Do not worry about it. Okay, do not worry about it. Let me just go through as accordingly. Alright, so I have P, I have OP, but I want PR. So look at the direction, PR. And recall your concepts and note, PQRS, it's a parallelogram. Okay, if the diagonals intersect at O, what does it mean? My diagonals over here, we call sec 1, they are bisected. So therefore, these two are sort of the same length. And henceforth, if I were to do just a little magic, PR is actually, if I shift this around, if I multiply by -1 because it goes in the other direction, okay, which is 2 of negative P. This is none other than as such. Therefore, my answer for vectors usually in questions is bolded, therefore answer number 3. All of them look the same, but when it's bolded, it's usually a vector. That is for exams as well. If it's italics, it's algebra. If it's bolded, it's a vector. Okay, so I hope you all got this down. Looking at the responses, I think it's good. Let's move on accordingly. Bubble question number 8. Okay, so let me emphasize again. Okay, OP is P. Okay, OQ, it's Q. Okay, I'm going to write it down. This is the meaning of expressing OP and Q. Okay, let me just write it out. OP, it's P. OQ, it's Q. Okay, how would I express now RS? Take note right now. I want this vector, and that's where the more important part of it being a parallelogram is more important. Alright, so let's see how you guys do this. Launching the bubble launcher in 3, 2, 2, 1. Let's go. Alright, let's go, let's go. Alright, let's go. Recall it's a parallelogram. So what can I say about my vector RS? So when I talk about RS, take note, it's this one over here. How would I do this? That's the first thing. Take note. Take note of the errors made. RS, in this case, when I talk about vectors, the directions are very, very important over here, guys. That's good to know, Denise. That means you have the concept well ingrained in you for this particular notion. Okay, keep it up over here. Always remember, positive vibes over here, but keep it up over here. You're doing good. But for the rest hanging there with me who are still answering, try to grasp the concept over here. But you're doing good, Denise. That's where that's where it comes in handy over here. Last 30 seconds. So take note, first important thing to take note over here. What can I say since PQRS, for those of you to answer, it's a parallelogram. Very important. What can I say? Alright, last 5 seconds for those of you to answer. Answer accordingly. 3. Okay, I think most of you are a little bit confused here, so let's see what we have. Okay, so since PQRS is a parallelogram, okay, what can I say about this vector and how I link it over here? Okay, I can say, take note, RS is equals to QP. Make sense over here? But how do I find QP? To go to QP, I need to go from Q to O, O to P. Or in fact, since over here, it's my position vector, I can straight away apply. O is my origin over here. I can say it's OP minus OQ. What is OP? P. What is OQ? Q. So that's where this is my answer over here, which is P minus Q. Alright? Now, whenever they talk about origin, one thing to take note, whenever they talk about origin, they will usually label it with the alphabet O. So when you see the word O over here, it usually means origin. So that's one thing you can take note of and be assured. O over here means the origin. Okay, that's one thing you can take note before you apply this formula over here. How many more? There are 3 more to go. So that's where we have bubble question number 9. Okay, bubble question number 9. So that's where you will need a few things. Okay, I'm going to provide you a few things. It's a little bit harder now. OP is P, OQ is Q, and you will need RS for now. Okay, so I'm going to give you all the stuff that you have. Okay, so express ST. This is going to be a little bit harder. Okay, so let's see what we have. Okay, to solve this question. Okay, launching my bubble launcher. Take note, guys, in 3, 2, 1. All right, let's go, guys. Let's go with me. Okay, that's good. Some of y'all, I think you have superpowers. PS. Yes, PS over here, actually, you can work a little bit backwards. Okay, PS, you can work a little bit backwards because why? This is Q as well. So what is PS? Or in this case, SP. I'm giving you all quite some hints over here. Because this is, remember, this is my intersection, Isabel. So this is Q as well. This is P. So how do I find your PS in this case? And that is where you realize what other information you have. This one comes in handy. Right, so for the rest of you to answer accordingly. And from there, how do I answer ST? I mean, yes, ST, that's right. Last 20 seconds. Now from here, PS is actually what you need to solve first actually in order to get this question down. Okay, so take note, we have about just a little bit more. Last 4, 3, 2, okay, this one is a little bit hard, so let me go through first. So let's think about this. I want ST. So what is the ideal way to go from S to T? Okay, break it down from the question. Straightforward way, S to P, P to T. Now, how do I get SP? So if you look at my diagram down there, to get from S to P, I can go from S to O, then O to P. What is SO? SO, if you were to be from the diagram, since this is my whole diagonal, it cuts it at 2 equal parts. It cuts into 2 equal parts. Same direction, same length. This is the same vector. SO and OQ are the same vector. So therefore, SO is actually Q, OP is actually P. Or in fact, P plus Q. Convention, easier to see. Now from here, I want to get ST. So I have SP now. ST is none other than, in this case, P is none other than SP plus PT. But what do we have over here? Take note, I have PT, then I'm stuck. Look at the question, what do I have? I have this relation over here. So that's why I have to read the question and try to see what other relations you can get. If PQ is 5 of PT, I want to get PT. What can I say about PQ? PT is 1 over 5 of PQ. In terms of length first, we are talking in terms of length. But however, since the direction are the same, therefore this applies to the vector as well. 1 over 5 of PQ. Now what is PQ? Have we done this just now? That's why I provided this. Because, can anybody tell me? SP is P plus Q. If RS is P minus Q, what is PQ? It's the same magnitude, just that the direction is different. So that's why I multiply this by -1 to get me negative P plus Q. And from there, that's where we manipulate over here. We are going to get P plus Q minus 1 over 5 P plus 1 over 5 Q. Add them up, you are going to get 4 over 5 P plus 6 over 5 Q. Sorry for that, 4 over 5 P plus 6 over 5 Q. And now you realize I just need to factorize, so that's where I factorize out 2 over 5, and it gives me 2P plus 3Q. That's why my answer is number 3. Now, am I blocking the answer? Yeah, this is the answer over here. Now, some of you may ask, is it okay if I leave it like this? Answer is yes, it is okay. Alright, because I'm just finding the vector, they never say you need to factorize it out. Okay? Now, with that, what are the other questions they can ask you? Let's take a close look. This is a very, very typical question. Explain if they lie in a straight line. So, of course, what happens? I need to give you ST first. ST is this particular vector over here, which we have solved just now. Now, what do I need to do? I need to show if this lies in a straight line. It's clear over here it lies in a straight line, but how do I explain it? Okay, how do I explain it? Okay, look at the question carefully, okay, with the diagrams over there. Okay, so launching the bubble launcher, alright, take note. In 3, 2, 1. Alright, let's go. Alright, that's good. Okay, you only have 2 answers, yes or no, but try to do it out. Okay, it's obvious. It may be obvious, but it may not look like it. So I want you all to try it out to see how we can get towards it. Okay? So take note, ST. Previous question you have ST. Now I need S. What other vectors do I need to solve this? Take note, you only have 2 choices. If you provide me with choice 3 and choice 4, you're not going to get any answers there. Okay, sorry, I think you need an extra information. Sorry for that. You need to know that OU is 2/3 of OP. Sorry for that. Okay, so providing this information, let's see how you all do it. Sorry for that. You'll need this information over here. I am so sorry. Yes, so this information over here is what you need. Okay, sorry for that. Okay, I hope it doesn't cut too much of your time. But you will need this information over here. And then in this case, how do we find it? Okay, very important. Last 15 seconds. Last one. Okay, let's take a close look. Okay, so if you look at this question, most of you got it right, but why so? What is the working? Now you will need this information. Apologies for not providing it just now, but I'll write it out, and in future lessons, it will be printed out as well, so don't worry. Okay, now, if I have this, OU is 2/3 of OP. So what does it mean? We know P over here is this vector. Q is this vector over here. Okay, so what does it mean? This means that OU is 2/3 of OP and henceforth 2/3 of P over here. Okay, now I have ST. What vector do I still need? Can anyone tell me what is another vector that I can find to show this relation? And yes, to see whether you understand what is the meaning of lie in a straight line for a vector. What vector do I still need to find in order to prove what lie in a straight line means? Alright, let's take a close look. Yes, collinear, that's right, Dennis. But what is the vector I need to find to prove collinear? I have ST. What is another vector I need? Collinear means what? Let's bring it up. Very good, Denise. Anybody else wants to try? It's going to be S. We have found that vector just now. U. S and U. Okay, let's recap over here. What is SU? O is the origin. Take note, it's given in the question here. O is the origin. So therefore, I have OU minus OS. This shortcut is always very useful. So just use it. OU minus OS. What is OS? OS is this direction. So in this case, just now remember, SO is Q. OS is minus. OS is minus Q. So minus Q. Okay, minus Q. Take note over here. It's not just minus Q. So this vector SU, in this case, let me just write it out over here. SU is then therefore, okay, 2/3 of P plus Q. Okay, now how do I solve it further? So that's where you realize if I want to find ST, how do I compare? Now, what is the relevance over here? ST, recall, is 2/5 of 2/3 plus 3Q. Now, if I were to sort of do some manipulation over here, what can I do? Okay, now take a close look. You realize if I were to break out SU even more, I can say SU is actually, if I bring out 1/3, it's going to give me, okay, 2P plus 3Q over here. It's a little shortcut, 2P plus 3Q over here. If I bring out my 1/3, okay, so what is this relevance? You realize there is a particular 2P plus 3Q on both sides. That is one thing. Collinear requires them to have the parallel notion, because not only they have to have the same line, but they are also of the same direction, which is where parallel comes in. So therefore, 2/5. How do I manage to extract this vector out? Let's play a bit with the numbers. You realize 2/5. If I have 6/5, multiply by 1/3. So that's where you play with the numbers of 2P plus 3Q. And that's where you have ST is equals to 6/5 of SU. This is the very important thing to show that it is lying in a straight line, because one thing to take note, let me write it here. Since ST, again, it's equals to a constant of a vector, which is over here, and also they share a common point. They share a common point. This shows that they lie in a straight line. Or in fact, you can just say S, U, and T are collinear. All right, SU and T are collinear. That's one thing. You have to show that they are parallel, which is this notion over here. Okay, so I hope you all got this down. Main thing, collinear, you have to show that either ST it's parallel to SU, SU is parallel to TU, as long as they have a common point. Okay, now there's one more bubble question to go, and let's see what we have over here. Take note, I will need to provide you from this in order to solve this notion over here. OU is 2/3 of OP. Alright, last bubble question for today. Let's see how you guys fare it out. Launching a bubble launcher in 3, 2, 1. This is a very common question. Let's go. Very, very common question that will usually come up. This is a very common question that will usually come up in terms of vectors. Okay, you will just need this notion in order to solve. Always ask yourself, okay, this is actually in vectors, it's not really squaring in or what's not. Okay, you have the triangle PUS, you have your triangle OUS now. Say for example, what is the fraction I am finding out? Take a close look. How do I find the fraction or ratio? Area of PUS, area of OUS. How do I find out the fraction? Okay, this ratio is very, very important. I mean, this fraction, this relation is very important for you to solve this. Last 5 seconds, hang in there with me. 3, 2, 1. Alright, okay, I'll need to go through this, so listen up. Alright, now, PUS, you realize is this particular notion here. OUS is this particular triangle over here. Nothing is given to us, so how do we even find out the area in the first place? The only thing we know, OU is 2, OP is 3 in ratio. So in terms of units, can we say this is 1? Makes sense, right? Now let's bring it up. Area of PUS. I only know this is the base we can use because these are numbers. Where is the height? This is the technique for this question whereby you actually have to find a common height between the two triangles. And in this case, say H. This is my common height. Once you find this common height, very crucial question. Usually this type of questions will come up when it comes to area and vectors. You have half times PU, and take note, perpendicular height over here. I'm looking for the perpendicular height. So that's why half times PU times my height, H. Over, that's where the next one, it's OU times H. Common terms cancel. What is PU? What is OU? PU it's 1, OU it's 2. That's why it's number 2. I understand this question is a little hard, so there's a Q&A later. If you need any queries, feel free to actually stay back. I'll be more than happy to answer them. Otherwise, that's it for me today. What we have revised, we have applied it over here to your DIY. Try it yourself. Give it a shot. Try it out. It encompasses all the concepts over here. So just give it a try. It's another variation. 50 bubbles up for grabs. So not only you get to revise your concept, you get to actually earn some bubbles for yourself, to reward yourself. So that's all for today. Thank you everyone for staying with me. This is what we have revised. Until then, this is Teacher Jason signing off. Any queries, please ask me later. Otherwise, stay tuned and I'll see you all next week. Alright, this is Teacher Jason signing off. Alright, take care everyone. Bye bye.